Here we're going to talk about factoring and how you can figure out the answer to a problem on the state test that's asking you to factor without completely factoring from scratch. So first off, I want to show you about greatest common factors. If something has a greatest common factor, there's a number we can divide them both by. So like 16 and 24, we can divide them both by 4. 4 is the greatest common factor. Here, 16a and 14a. I can divide them both by 4, but I can also divide them both by a. They both have an a and a 4 in common. How about now? I can divide them both by 4, and they both have at least one a in common. So the greatest common factor would be 4a. Here, they both have a 4 and an a, and then they both have at least 2 b's in common. So I can divide them both by 4a squared b to the third. So if you look at this one, what is the greatest common factor? I can divide them all by 5, and I can divide them all by b. They all have at least one b in common. So what factoring is taking a polynomial and changing it to a multiplication problem. So you look at that 4a squared and you look at that 8a and you realize I can divide them both by 4. I can divide them both by a. So I can factor out that factor 4a. And what's left, I leave in parentheses. So on the state test, you can eliminate choices when they're asking you to factor a polynomial if the choices are not fully factored. So if one of your answers has 3x plus 12, is 3x plus 12 fully factored? No, because I can divide 3x by 3 and I can divide 12 by 3. I can factor out a 3. And when I do, what's left? 3x divided by 3 is x. 12 divided by 3 is 4. So it factors to 3 times x plus 4. So if you're given this as an answer, is this fully factored? You want to look at each set of parentheses individually. So 3x plus 12. Remember, that's not fully factored. I can divide them both by 3. And then x minus 5, is that fully factored? Yeah, there's nothing I can divide x by that I can also divide 5 by, besides 1. There's nothing I can kind of pull out as a factor of both x and 5. So now our answer is fully factored. So this was a state test question, and what I would ask you to do is first, they're asking us to factor that polynomial here. You want to look at the choices and see, are there any that I can eliminate because they're not already fully factored? So which of these can I cross off because it's not fully factored? B. B is not the answer because 3x plus 6 is not fully factored. I can divide 3x and 6 both by 3. I can factor out something else. So B cannot be the answer. How about these? Which one is not fully factored? D. 2x plus 6 is not fully factored because I can divide them both by 2. And so the answer must not be D because that choice is not fully factored. So if you eliminate those two choices, we're just left with 2 answers that could be right. It could be A or C. Now from here, a way that you can figure it out on the state test is to graph that yellow original polynomial, see what it looks like, and then graph A. See if it's the same graph. And then graph C. See if that's the same graph. When you have a polynomial and you factor it, it's the same equation. You're just changing it to a multiplication problem. but it should look exactly the same when you graph it. So for a question like this on the state test, you're looking for the choice that is fully factored, that when you graph it, looks like that original function.